All right, so we are going to continue our work on page 13 with measurements, and here's where I kind of highlight for you guys why significant digits are so helpful. So you see, I've got a note here that science, you're not going to have to worry about asking where you need to round. The significant digits, or SD for short, are always going to tell you. So that's where we're going to build this out right now. So again, on page 13, underneath the significant digits and measurements work that you already did from the other at-home learning day, we're going to pick up there. So first, we've got addition and subtraction rules. I'm going to show you some examples. First, we've got thinking about money, because that's just how our brains work. So first, I've got $2.87. So that means that I know exactly how much change I have. I've got $2 and exactly 87 cents. So that means that I would have 3 significant digits there. That'll come up a little later on. And then let's say that I'm going to add to it a certain amount of money, but this time I only know that it's about $11. Okay, so I've got a friend who is going to lend me some money, anything that's in their pocket, and they've got about $11, and they aren't sure how much change that is, so they hand that over to me, and I need to know just really quickly offhand how much that's going to be. So when I add this together, I end up with $13.87. But remember, I didn't know how much change was there for that $11, which means that whenever I'm figuring this out, this 87 cents right here actually can't count. Okay, so that 87 cents I'm going to need to get rid of, which means that I need to think about how is that going to impact my 13. So I need to round using this 8 and figure out what's that going to do to the 13. It is over 5. 5 and over is going to round up. So I end up with $14 roughly. Okay. Then number 2, I've got, let's say I've got $80, but I know it's $80 specifically. It's not like maybe 76 or anything like that. It's $80 and I just don't know the change, so I need to put a decimal after the 0. And this time I'm going to add $20.72. $20.72. Then that means that I've got 100.72. But again, I didn't know how much change was with that 80. So then this 72 needs to get taken out here. So I've got 7, which is going to round this 100 up to a 101. So 101. And anytime you write numbers in here, make sure that you circle those answers and give me any units that are with it. So just kind of something to keep in mind. Then number three is going to be $9.7 and 2.8 we're going to add. 7 and 8, that's going to be 15. Carry my 1 up there because that's going to now be in the ones place. 1 plus 9 plus 2 is going to give us 12. Carry that decimal down right here. And what is a big deal here is because all my numbers had the same least significant digit, okay, the same least significant digit, that last decimal place that was significant, that means that I can keep this whole answer. All 3 of those numbers are going to be significant, and that'll give us 3 significant digits. So this is my final answer then. Then 4, and then I'm going to give you guys an opportunity to try this with 5 and 6. We've got 4. This will be a subtraction problem. So let's say I've got $12 exactly. I know I'm the type of person that I've got like cash on me and I don't use change at all. So I've got exactly $12 and I'm going to buy some, let's say I'm going to buy a drink from Sonic, but I get like a bunch of add-ons and stuff like that. So I'm going to do subtract, and it's roughly $3. I don't know exactly how much it is, but it's roughly $3. So I don't know how much change it's going to be. It might be a little bit more than $3, might be a little bit less. So whenever I do this, I'm going to have about $9 left, because this decimal 00, that doesn't actually count because I didn't know how much change I was taking away. Okay? Because of that, again, we need to round. Look at the last decimal or number right before the first significant digit. It's a 0, which is under 5. Under 5 is going to keep it the same. So it's going to round down or keep it the same, which means that my final answer here is that I've got $9. Okay? So these next two, I want you to try and then put your answer in and see how we do. So this number 5 is $2.50, and we're going to add $5 to it. When you get that answer, you should have $7.50. And because all of those are the same, the last significant digit on all of them was the hundredths place here. I can keep all three of those. So my answer is $7.50 exactly. Then 6, I've got 10, but I know exactly 10. I don't know how much change I've got though. And then I'm going to subtract away from that. So $10 minus $7, and this time I know I'm subtracting away exactly $7. When you do that, you should get 300. However, again, we look and the last significant digit on that 10 is the ones place, so the 3 is the only thing that we can keep. I got to get rid of these zeros, check rounding. I look at the 0, that's going to round the 3 to a 3. It's going to keep it the same. So my final answer is $3-ish, because I don't know the change. Next, we've got multiplication and division rules, and the thing here is we can keep the least number of significant digits. So keep least number of significant digits. And again, you'll see me abbreviate that as SD. So least number of significant digits is what we're going to keep. So before we do that, let's look at number 1 and just get the final answer out of that. So we've got 3.11 times 2.0, and while you guys are at home doing at-home learning, you guys can just use either a phone to do that calculation, or you can use your Chromebook or laptop to do the calculation. We end up with 6.22, and then we need to figure out the least number of significant digits. So first, I've got 3, 1, and 1. All three of those numbers are significant because they're non-zero digits, and that means that it's got 3, and then the 2.0, the 2 is obviously significant. The 0.0, because it comes after a decimal and a non-zero number, 2 is non-zero, that's also significant, so that one has 2. So I can keep 2 significant digits on this problem. So I look and I see I've got the 6 and the 2. So this 2 right here needs to get rounded off, and I check it. It's less than 5, so that means that it's going to round down or keep it the same. So my final answer with no units, because I wasn't given any units, is 6.2, and circle it. Then 6.002 times 4.8, and when I do that calculation out, I get, you guys go ahead and get that, you should end up with 28.8096. And do a quick check again. Again, we've got 1, 2, 3, 4 significant digits on that first number, only 2 on this second one, so I can keep 2. The 28 is going to get kept. Check the next one that I'm going to get rid of, which is that 8. It is 5 and over, which means the 28 is going to round up to 29. Again, no units because no units were given there. This next one, I don't think you can see that, so I'm going to rewrite that. It's 104.2 divided by 8.0. And when I do that out, answer is going to be 13.025. Check my significant digits. Top number has how many? It's got 1, 2, 3, 4. Bottom number has how many? 1, 2. I can only keep 2 significant digits, so I come over here and do 13. The 0 is going to round that to a 13 because it's going to stay the same because it's less than 5. So 13, again, no units because no units were given. Then 18.12 divided by 4.0003. And when I do that math out, I end up with 4.5266. And it goes on for quite a bit longer than that. We're going to put ... for now because I'm pretty sure that significant digits are going to make it to where that doesn't matter. So let's check significant digits real quick. I've got 18.12 has 4, 4.0003. All of those zeros are trapped between non-zero numbers. So all of those are significant, which gives me 5. Between 4 and 5, 4 is the least number of significant digits, which means that I can keep 4 significant digits. Keep 4 significant digits. So go ahead and try, what is that going to be for this number? You should get 1, 2, 3, 4, and the last number here, so we kept as many as we needed to be able to figure this out. If you didn't, you would need to go check what is the rest of those numbers real quick. But 6 is more than 5. It's going to round that 6 up to a 7. So I end up with 4.5267 as my final answer. Now, you guys try number 5 real quick. For number 5, you should end up with an answer of 2,177. First, check significant digits. I've got 1, 2, 3, 4 on that first number. Because there's no decimal after the 700, this is only a single significant digit. So I've got 1 significant digit here, and that's going to be the 2,000. So I check my hundreds place because that's the next number here and see if it rounds. And that's going to tell me that this number is closer to 2,000 than it is to 3,000, which means I'm going to round it down, okay? Or keep that 2,000 the same. So my final answer is 2,000 here. Then try number 6 for me. Number 6, I have 800.2, and divided by 535, I end up with 1.4957. Check significant digits. Should have 1, 2, 3, 4 on that first number, only 3 on the second, which means I can keep 3 significant digits. And that means that I've got I've got 1, 2, 3. 5 is going to round the 9 up. So 1.49 is going to round up to the next closest number because it's a 9. It's like that 49 is rounding up to a 50. So my final answer is 1.50 because I need to make sure that this spot right here is still significant, because otherwise it looks like it only has 2 significant digits. Then accuracy and precision. For accuracy, we're looking at that it's close to the actual value. So it is seeing how correct is the measurement. Okay? For precision, we're seeing that it's close to the other measurements. So this one is seeing how consistent or how repeatable. If you were looking at these dartboards, you see that this first one, all of the darts are right here in the center. They're on that bullseye, which is the correct value, if you will. That's what we're trying to get to. So they're accurate because they're all right here. Their average is where they want to be. They're precise because they're all clumped up really close together. On the second one, we've got poor accuracy because where they want to be, we want to have an average that's right around here, and it's actually way over here. Then it's good precision, though, because instead of being all spread out, they are still really close together, all right in this area. So it's good precision. Then on this last one, we've got poor accuracy and poor precision. So poor accuracy, if you look, their average, when you average all these together, it's actually going to be somewhere around there. So it's not hitting the target where you want it to be. If you averaged all those together, good accuracy would be in the middle. Then poor precision, because they're all over the place. They're not in any one spot. And this last part here, we've got a table with some measurements, and you see the actual value is 2.4 centimeters. So what I want you to do is I want you to use what we've done talking about accuracy and precision to figure out, were either of the students accurate, which one and why, and then were either of the students precise, which one and why. Okay, so go ahead and answer those, and then see if you have any questions about that.